Hello there, welcome to the October 2020 applied paper. Here we're looking at the first question on the mechanics section. That's question 6 in the paper overall. A rough plane is inclined to the horizontal at an angle alpha, where tan of alpha is 3/4. A brick P of mass m is placed on the plane. The coefficient of friction between P and the plane is mu. Brick P is in equilibrium and on the point of sliding down the plane. Brick P is modelled as a particle. Using the model, find in terms of m and g the magnitude of the normal reaction of the plane on the brick P. Okay, so let's draw ourselves a little diagram. We have the brick at this point here. We have its mass, which is going to be mg. We have alpha, that's the angle here. The normal reaction is going to be this reaction here. And the friction, given that it's on the point of sliding down the plane, and friction is always against motion, is going to be acting up the plane. So there we are. From the description that we're given in this question, this is the diagram that we can draw. So now if we want to work out the normal reaction, that's this reaction force here, that's R, we have to resolve the force of this weight force of the brick. So that's going to be mg cos alpha and mg sine alpha. And then for part A, to work out what R is equal to, we're just going to resolve the forces that are perpendicular to the plane in that direction. So that's going to be R, that's acting upwards, away from the plane, and mg cos alpha, that's acting into the plane. And we may want to simplify our answer by giving an actual answer for what cos of alpha is equal to. Let's just remind ourselves that tan alpha is equal to 3/4. So when I draw myself a little triangle, it's going to be 3 on the opposite, 4 on the adjacent. That makes it 5 on the hypotenuse. So for the cos angle, it's going to be 4/5. So R equals 4/5 mg. And there we are, that's our answer to part A. Moving on to part B, show that mu is equal to 3/4. Well, the way that we're going to do this is we're going to be resolving parallel to the plane, so up and down the plane. So all the forces down the plane, which is going to be mg sine alpha. So mg sine alpha. Sine alpha is going to be 3/5, so it's going to be 3/5 mg will equal the friction force. Now we can use F equals mu r for the friction force because it's on the point of moving down the plane, so that's going to be 3/5 mg equals mu, which we don't know, times r, which we do know, 4/5 mg. So now let's cancel out the 5's on both sides, cancel out the m's on both sides, cancel out the g's on both sides, and divide both sides by 4. That's going to give us 3/4 equals mu. So there we are, that's the answer for part B. Moving on to parts C and D now. It says here for parts C and D you are not required to do any further calculations. Brick P is now removed from the plane and a much heavier brick Q is placed on the plane. The coefficient of friction between Q and the plane is also 3/4. Explain briefly why the brick will remain at rest on the plane. So the reason that Q will remain at rest on the plane is because as we've done all our calculations here, the mass has just cancelled out. So it doesn't really matter if the mass increases or decreases, the mass will always just cancel out. So it's always just going to remain in equilibrium if brick P remains in equilibrium. So the value of m cancels out. So Q will also remain in equilibrium. Okay, and moving on to the next part, brick Q is now projected with a speed 0.5 meters per second down a plane of the line of greatest slope of the plane. Brick Q is modelled as a particle. Using the model, describe the motion of brick Q, giving a reason for your answer. Well, there's going to be no acceleration down the plane, no acceleration because the forces are still in equilibrium, as the forces are still in equilibrium. So you're not going to get anything out of an F equals ma equation because the sum of the forces is 0, so your acceleration will be 0. So therefore the particle, the brick Q, will continue to slide with a velocity of 5. Okay, so there we are. That's the answer for part D, and that's the answer fully for question 1, worth a total of 9 marks there. Let's now move on to the second mechanics question.